Hey there, Teacher Tandy here. Today I'm going to be showing you how to use this application, Scratch. Now, Scratch is a programming language which is designed to get kids to learn how to program by writing programs which will make cartoonish animations using characters like this. Now, there's a link in the description box below to download Scratch, and the inspiration for today's lesson comes from a website which I've also linked in the description box. But the code that I'll be writing is my own creation. It's not based on that website. So, let's get started. Okay, so what we're going to be doing today is that we're going to be writing a game which involves a cat being chased by a dog, and you have to control the cat to avoid the dog for as long as possible. Now, this is the cat that we'll be controlling, and this white box around him is the environment of the game, which means that neither the cat nor the dog can go out of this white box. So at the moment the cat is a little bit too big for the environment, so we need to make him smaller. You can do that by clicking here, and then clicking a few times on the cat. That should do it. Okay, now what I want to do is to change the background of the environment so that it looks a little bit nicer than just being white. And to do that, I can click on stage down here in order to change the stage, which is the background basically. And I click on backgrounds and import a picture. Now, what I'm going to be choosing as a picture is a picture of stars, so that it looks like the cat will be running in space. Okay, so we have made the cat smaller, we have given the environment a background. Now we can start coding. So the first thing we should do is to make sure that we are selecting the cat icon down here, because we want to control the cat. And we also need to make sure that we have scripts selected over here. Now this is the area in which we will write our program in order to control the cat. And you write a program by using these blocks over here. And you can change the blocks by clicking on these tabs over here. Now, if we're going to tell the cat what to do, the least we can do is give him a name. So I'm going to change his name. At the moment it's Sprite 1, but I'm going to change it to Ginger. Okay, now, to tell Ginger what to do, we first have to tell him when he should do it. To do that, you use one of these wavy blocks, which is this or this. And I'm going to say, hey Ginger, when the green flag is clicked, which is this, when the green flag is clicked, I want you to move 10 steps. Now, 10 steps is just a unit of measurement of distance in Scratch. The cat won't make 10 steps with his feet, it's just 10 pixels. Right, so he'll jump from here to 10 pixels in front of him. And I can try that out. See? He has moved 10 pixels forward. I can click that again, and he'll move another 10 pixels forward. Now, what I can do is to tell Ginger to walk 10 steps forward for 10 times. So what this means is repeat for 10 times, move 10 steps. So for 10 times, Ginger will move 10 steps forward. So how many steps in total will Ginger move? 10 for 10 times is 100. See that work? See? And now it looks like he is actually moving smoothly rather than jumping around. I can drag Ginger back. Try that again. See? And I can even make him move further in front by changing that from 10 to 20. That way Ginger will now move 200 steps forward. See? Okay. Now, what I want to do is to make Ginger look like he's moving his little legs as he moves forward. Now to do that in Scratch, you can use costumes. And costumes are basically different appearances of the character. So at the moment, Ginger has 2 costumes. This is what we're seeing at the moment, and we can change his appearance to this. And by switching between this and this, it can look as if Ginger is moving his legs. Now how do you change costumes? Well, you can go on here and choose the next costume block. See? By the way, you can remove blocks and even delete them by dragging them outside. But I want to put that there. Okay, so now what will happen is that Ginger will make 10 steps and switch to the next costume, and again move 10 steps and switch to the next costume, and again move 10 steps, etc. for 20 times. Let's see that work. Okay, now Ginger is in the moment moving a little too fast for us to see his legs moving clearly. So what we can do is we'll make Ginger wait for some time before making the next 10 steps. And we'll make him wait for 0.01 seconds. So what will happen now is that for 20 times, Ginger will move 10 steps forward, change costume, and wait. Move 10 steps forward, change costume, and wait for 20 times. See? Much better. Okay, now we don't want Ginger to just walk 20 times forward. We want Ginger to walk forward forever. And to do that, we can use the forever loop rather than the repeat loop. The forever loop will do whatever is inside it forever, not just for 10 or 20 times. Notice that you can't attach anything underneath it because nothing can happen after it. Forever will keep on repeating forever and will never leave. You can never leave the forever loop. So you can't attach any blocks underneath it. Okay, so I'm going to try this, and when Ginger will reach the edge, he'll get stuck there basically. See? And I can drag him back. Now what I want to do, in order to make Ginger controllable by the user, is to add some code which checks if the user is pressing any keys on the keyboard, and in which case that will change what Ginger is doing in some way. Now to do that, I use the if block, and the if block does what is inside it if something happens. What should happen? If the user presses a key on the keyboard. And I'm going to check if the user is pressing the left arrow key. And if the user presses the left arrow key, I want Ginger to rotate anti-clockwise. Let's try that. See? Now it's not just the left arrow key that should work, obviously. We need to also check the right arrow key. And to do that, I can just right click on that if block, duplicate it, insert it underneath, change this left arrow key to a right arrow key, remove this, and turn instead clockwise. Now we can make Ginger go around in circles and basically change the direction that he's flying in space in. Now, the challenge of the game is that you can't stop Ginger, you can only change the direction that he's going in. Okay, now it's time to add a antagonist to the game, an enemy, so we'll add the dog. And to do that, we click over here, we find a picture for the dog, and I'm going to choose this one. And this is the dog, and at the moment the dog is a little too big, so I'll make him a little smaller. Not too small though, he has to look like a real dog. And I'll change his name to Butch. Okay, now Butch should have a program in order to chase Ginger. Now, to write the program for Butch, we should make sure that Butch's icon is selected rather than Ginger's. Notice that there isn't any program anymore. Why? Because this is where you write Butch's program. And if you click on Ginger, this is Ginger's program. So two different programs control the two different characters. Okay, now I'll be doing the same thing. I'll say, hey Butch, when the green flag is clicked, I want you to forever point towards Ginger and move forward. Now obviously, if I try this, Butch will immediately catch up with Ginger. The reason is because Ginger has to stop and wait for 0.1 seconds after every 10 steps, while Butch doesn't. So I'll make Butch look like he's running by adding costumes to him, just like we did with Ginger. And this time I have to import the second costume because we have created this character ourselves. And I will find, here it is, the second costume. So now Butch will look like he is moving his legs as he walks. And again, I will make him change costume after every 10 steps, and we'll make him wait for 0.01 seconds. Now, in order to make this game a little easier, we should make Butch move less on every step so that it'll be easier to outrun Butch. So instead of moving 10 steps forward on every step, instead he'll move just 5. So now, okay, great. See, already a decent game in just a few minutes. This is the nice thing about Scratch. You can write cartoonish, cool games really easily without too much complexity in the code. See, everything is easy to do. Okay, now at the moment nothing happens when Butch catches up with Ginger, but what we're doing is that we have to drag Butch and Ginger apart after every game. So how about we solve that first? The first thing that should happen before the main loop starts is that both Butch and Ginger start in their initial positions. And you can check what coordinates those positions are by checking what is written down here. So Butch is at 100 minus 150x and 0y, and Ginger is at 150x and 0y. So I want Ginger to start at start at 150x and 0y. They also want him to point towards Butch, to the left. And Butch, on the other hand, I want him to start at minus 150x and 0y, and I want him to point towards the right. Let's see that work. So the first thing that will happen when the flag is clicked is that they start at their initial positions, and then the main loop starts working, in which they start running around. See, and now, even if Butch catches up with Tom, we start that game again, they will start at the same position. Okay, now what I want to do is to tell Butch to notice when he is touching Ginger and to stop the game, because in that case the loser has lost. Ginger has been caught. So I go in Butch's code and I insert an if statement which checks if Butch is touching Ginger. And we can use this. And I say, hey Butch, if you're touching Ginger, then stop all execution, stop all the programs of every character. And in that way, you'll notice that you have lost. Okay, now let's try that. See, the program stops. We have to start again, and when that happens, when we start again, they'll start back in their initial position. See? Okay, now it's not much fun stopping the game when you lose. You need to be able to restart so that you don't have to re-click the green flag. So rather than stopping the program, what I want to do is to go back to the initial position as soon as Ginger has been touched. Now, I also want Ginger to go to his initial position. So how will Butch tell Ginger that he has been touched and he should go back to the initial position? Now I can make Ginger also check if he is touching Butch, but there's a better way to do that, and that is to broadcast messages, to make the characters talk among themselves. So I want Butch to tell Ginger that he has been caught. I create a new message, and I want Butch to give the message to Ginger, which is caught. You've been caught. And I want Ginger to pay attention to that message and to say, hey Ginger, when you receive the message that you've been caught, you should go back to your initial position. See? Now the nice thing about messages, about broadcasting messages, is that the character that sent the message can also listen to it himself. So Butch can also pay attention to that very same message. And I'll say, hey Butch, when you tell yourself that you have caught Ginger, you should also go back to your initial position. And the nice thing about this is that you're separating the concerns of the program, you're separating what the programs should do. So this program only takes care of the main activity of what the character mainly does, and this just says what the character does in case he has caught Ginger. Right? Now, when this happens, when the caught message has been broadcast, the main loop will still continue running, but the X, Y, and direction will be reset to their initial settings. So although this will still be working, both Butch and Ginger, although their main loop will still be working, both of the characters will have restarted at their initial position. And this will continue working. They'll continue moving, // forward, changing costume, blah 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 blah. So let's see that work. See? Every time that Butch catches Tom, they both go back to their initial position. There's something strangely satisfying about playing your own game. Okay, now what I want to do is to add a score of some kind. And a good score for this game would be the time that has passed since the game has started. In other words, for how long have you lost it before Butch would have caught you. Now to do that, we're going to need something called a variable. Now what is a variable? A variable is a word which represents a number, a word which means a number. An example of this is age. Your age, the word age, is representing how old you are. And the same word can mean different numbers on different years. So if you're 16 this year, the word age this year means 16, but next year it will mean 17, and the year after it will mean 18. Now, in the same way, we want to create a variable which means the time, which means how many seconds have passed since the beginning of the game. Now, where does this belong? Does the time belong to Ginger or to Butch? It belongs to everyone, so we'll put it in this stage. So we'll create a variable called time, and time starts out as being 0, but then we'll add 1 to it every second so that we keep track of the time, of the number of seconds that have passed. So we'll write a program in the stage now, and again we'll say, hey stage, when the green flag is clicked, I want you to forever change the time by 1. In other words, add 1 to the time. So it starts at 0, then it starts adding 1 to it. It becomes a 1, a 2, a 3, etc, etc. But we only want that to happen after waiting for a second. So every second the time will add by 1. I also want to make sure that the time starts from 0, so I set it at the beginning before the loop starts to 0. Now let's see that work. Time is 1, time is 2, 4, 5. See? We're adding 1 to time automatically every second. Now what we want to do is to make the time restart to 0 every time that Ginger is caught. So we'll make the stage pay attention to when Ginger has been caught, to the message that Butch broadcasts, And when that happens, we want to set the time to 0. Let's see that work. Let's start at 0, 1, 2, 3, 4, 5, and it goes back to 0. 1, 2, 3, 4, 5, 6. Goes back to 0, 1, 2, goes back to 0. See? Okay, now, in order to have a decent game, we should keep the high score. In other words, what the best time has been. In other words, which best time? What's the longest time that you have managed to keep before Butch finally catches up with you? Now, to do that, we need to add another variable called best time, and we will change this every time that the cat has been caught, every time that Ginger has been caught. So what we'll do is we'll add another variable called best time, best time will show here, and I want to, every time that Ginger has been caught, I want to check if the current time is better than the best time, and if it's longer than the best time, then that time should be the best time. So I'm going to need this, and this means greater than, and I'm going to say, hey stage, if the current time is greater than the current best time, then set the best time to be the current time. And this will look like this. So if the time is better than the best time, then set the best time to be the current time. See, does this make sense? The best time is only set to the current time if the current time is greater than the best time. Let's see that work. So the best time at the moment is 0. Now it's 6. It remains 6. It's still 6. But if you last for longer than 6, see, it's 7, 8, now it's 9, the best time. So the best time has only been changed because we have reached a better time. Now, if we try to play again, the best time is still 9. But that's not what we want, is it? We want the best time to start again from 0. So, when the flag is clicked, we want to not only set the time to 0, but also set the best time to 0. See? Isn't this cool? The best time is 2. Now it's 5, etc. See? And if we start again, it starts back from 0. Okay, now, what if we could also keep a list of all the times of the games that have been played? And to do that, we use a list. We create one called times, and this is where the list will appear. And what we should do is that every time that the user loses, we want to add the current time to the times, to the list of times. We'll add the current time to the list of times. And notice that it has nothing to do with whether or not it's better than the best time, because we want to add every time to the list of times. Now we also want to make sure that the list of times starts out empty. So we delete everything from on the list of times, and then we can start. Let's see that work. Okay, so first game lasted 2 seconds. Second game also lasted 2 seconds. Third game lasted 5 seconds, which is the current best time. Fourth game lasted 4 seconds, which didn't beat the best time. Fifth game lasted also 4 seconds, which didn't beat the best time. Sixth game lasted 6 seconds, which is the new best time. See? And now we can know how many times we have played, the times of each game, and the best time at this point. Now, if you had to try to do this very same game using another programming language, such as Java, this would have taken much longer to do. And it would have been much harder as well. Scratch, all the instructions are really easy. They're easy to use, they're easy to understand, and the programs are quite fun to do as well, which might not be the case in Java. Now, you can add your own features to the game, such as making Butch go faster every second, or adding power-ups which make Ginger speed up, or teleporting, or becoming invisible and making Butch stop chasing him, or other things like that. Let me know of any new ideas that you have actually tried yourself in the comments below. I look forward to seeing them, and I'll see you next time.